So in this session, we'll discuss a number series and letter series, which are very important for bank exams and bank PO, especially bank PO and bank clerk prelims exams and SSC as well as railway exams. For all these exams, number series and letter series are important. Not only prelims level models, there are some questions we have taken up of mains levels also, sample questions. We'll discuss those questions also. In prelims exams, in bank PO prelims exam or bank clerical prelims exams, you will be given 4 to 5 questions from the area of number series. If it is the SSC or railway exam, in reasoning section, you will be given 1 or 2 questions from the number series and letter series together. 1 or 2 questions. And 4 to 5 questions in bank PO prelims or bank clerical prelims. It could be IBPS PO or RRB regional rural banks PO. Any exam, minimum 4 to 5 questions will be given. And this topic they will not give you in the as a part of reasoning. As it is not, it will be not given as a part of reasoning. You will be given in quantitative aptitude section or numerical ability section or numerical ability section. So it will be not given in reasoning section, numerical ability or quant section. You will be given this number series in bank exams. In SSC and railway exams, you will be given in reasoning section only. Reasoning and general intelligence section, you will be given number series and letter series. 1 or 2 questions are expected from this topic. Now, so first we'll discuss the basics. The main agenda of this session is you need to understand the basics, how they form the questions. That you need to understand first. And after that, what are all the different models they may give. I'm not giving the exhaustive list of logics or exhaustive list of models, but the important models they are giving in the recent exams, I'm going to cover here. And we have also taken some memory based questions of previous years. We will discuss that questions also, prelims questions as well as mains questions. Now, to answer the number series questions, first we should be thorough with the fundamentals and basics. Those are natural numbers, odd numbers, even numbers, prime numbers, composite numbers, and non-prime numbers. You know, natural numbers are nothing but countable numbers. Starts from 1, 2, 3, and so on till infinitive. Countable numbers. Odd numbers. The numbers which are not divisible by 1, not divisible by 2. 1, 3, 5, 7, and so on. Even numbers. The numbers which are exactly divisible by 2. 2, 4, 6, 8, and so on. What I mean, why we have to remember this? Why we have to recollect this? You know natural numbers, you know odd numbers, you know even numbers, and you know prime numbers, composite numbers, and non-prime numbers. You know everything. But why? What is the purpose of recollecting these numbers again? See, my dears, in number series, you will be always and always coming across only these patterns. Natural number pattern, odd number pattern. It may be any logic, it may be any logic, but the fundamentals will be same. The series may be of natural numbers or odd numbers or even numbers or prime numbers, composite numbers, and non-prime numbers. Could be consecutive or maybe alternative. That pattern you need to identify. First, you need to identify the logic and then you need to identify the pattern. That is very important. And what are the prime numbers? 2, 3, 5, 7, 11, and so on. The number which is divisible by 1 and itself, or the number which is having exactly 2 factors, are called as prime numbers. 2, 3, 5, 7, 11, and so on. So what I suggest you is try to remember the prime numbers from 1 to 100. From between 1 to 100 you will be having total 25 prime numbers. Try to remember these 25 prime numbers, which will definitely helpful to you when you are attempting the exam, when you are solving the questions from number series. Now, what are composite numbers? Other than prime numbers, all the numbers are composite numbers except one. One is neither a prime nor composite numbers. So, what are these composite numbers? 4, 6, 8, 9, 10, and so on. One is neither a prime nor composite number. Non-prime numbers. What are the non-prime numbers? Other than prime numbers, remaining all numbers are non-prime numbers. 1, 4, 6, 8, 9, 10, and so on. Clear? So, what is the importance of these patterns? When we are discussing the example, I will relate them so that you can understand that what is the importance of these patterns. Okay? Now, what kind of logics will be given? What kind of logics you come across in the exam? That we'll discuss. Right. So the first one is consecutive logic. You need to understand what exactly consecutive logic. Numbers themselves follows a specific pattern. Numbers themselves follows a specific pattern. Like a question may be given directly consecutive even numbers. You may be given a question like this: 12, 14, 16, 18, 20. What is the next number in the series? See, you won't be given this much easy questions. But sample example I am giving to explain the concept of consecutive logic. Numbers themselves follows a specific pattern. Here numbers are following a pattern of consecutive even numbers. The numbers are following a pattern of consecutive even numbers. First understand the pattern, how the questions will be formed. If you can understand that, answering the questions will be very easy. Consecutive even numbers. Okay. Now you may be given one more example like this. 23, 29, 31, 37, 41. What is the next number in the series? And you know, 23, 29, 31, 37, 41 are consecutive prime numbers. What is the prime number after 41? 43. So here numbers themselves following a specific pattern. What is that pattern is? Consecutive prime numbers. Consecutive prime numbers. Numbers themselves following a specific pattern. For example, a question is given like this: 1, 4, 9, 16, 25. What is the next number in the series? Here also numbers are following a specific pattern. Are you able to recognize these numbers? 1, 4, 9, 16, 25. Natural number. Sorry, square numbers, perfect square numbers. Squares of natural numbers: 1 square, 2 square, 3 square, 4 square, 5 square. What is the logic applied here? What is the logic applied here? Logic applied is square, but what is the pattern? This pattern is very, very important. Understanding the pattern is very, very important. What are these numbers? 1, 2, 3, 4, 5 are consecutive natural numbers. Here comes the importance of pattern. So after 5, what is the natural number? 6. So here the pattern is natural numbers. So these patterns are very, very important. Now here I have taken example with consecutive natural numbers. You may be given squares of consecutive odd numbers, squares of alternate odd numbers, squares of consecutive even numbers, squares of alternate even numbers, squares of prime numbers, squares of composite numbers, squares of non-prime numbers may be given. Ultimately, the important thing is here you need to recognize the numbers as a squares, the given numbers as a squares, you need to recognize it. After recognizing the given numbers as a squares, you need to identify the pattern. The pattern could be one among these. Always the pattern will be one among these: natural, odd, even, prime, composite, and non-prime numbers. Any number of questions you solve, any number of questions you solve, the pattern will remain same: natural, odd, even, prime, composite, non-prime, either consecutively or alternatively they will give you. Right. So here, what is the consecutive logic means? Numbers themselves follows a specific pattern. Numbers themselves follows a specific pattern. Right. Now see here, squares and cubes. Consecutive logic. Natural number squares, odd number squares, squares of even numbers, squares of prime numbers, squares of composite numbers, squares of non-prime numbers, cubes of natural numbers, cubes of odd numbers, cubes of even numbers, cubes of prime numbers, cubes of composite numbers, cubes of non-prime numbers, right? This is the way questions will be formed in this consecutive logic. Numbers themselves follows a specific pattern. And my suggestion is squares try to remember up to 30. 1 to 30 squares try to remember it. Try to by heart them. And the cubes 1 to 15 cubes. Try to by heart them. Definitely this will help you when you are solving the questions, either when you are practicing it or in the exam. Squares up to 30, cubes up to 15, and prime numbers. It is also one of the important part. Prime numbers, first 25 prime numbers. Oh, very, very important. First 25 prime numbers. Try to by heart these three parts: prime numbers, squares, and cubes. Okay. Now let's move to the second logic. I hope you are clear with the first logic. First logic is consecutive logic. Here the numbers themselves follows a specific pattern. Right. Now let's move to the second logic, difference logic. Now here comes difference logic. Let us take an example. You will get the idea. 5, 6, 8, 11, 15. I'm taking very small numbers and small examples, easy ones to understand the concept. Now here, one number to the another number. First of all, you can understand that numbers are increasing. Numbers are in increasing pattern. Numbers are in increasing pattern. One number to the next number, one number to the next number, there is a small jump. Or you can say that numbers are increasing gradually. Numbers are increasing gradually, slowly. Numbers are increasing gradually. Whenever you see numbers are increasing gradually, you can apply difference logic. Whenever you see numbers are increasing gradually, you can apply difference logic. Okay. Now, what could be the difference? How the questions will be formed? That you need to understand. Now, here, what is the difference is 5 to 6, 1, 6 to 8 increased by 2, 8 to 11 increased by 3, 11 to 15 increased by 4. What are these numbers? 1, 2, 3, 4. Again, here comes the pattern. Natural numbers. Here comes the pattern. Natural numbers. So, what is the natural number after 5? After 4? 5. So, 15 plus 5, 20 will be your answer. Now, here it is a sample example where the difference is a consecutive natural numbers. Difference can be consecutive odd numbers. Difference can be consecutive even numbers. Difference can be consecutive prime numbers, composite numbers, non-prime numbers, or alternate even numbers, alternate odd numbers, alternate prime numbers. This is how the questions will be formed. Okay, you need to understand the concept here. Now let me take another example. 5, 6, 10, 19, 25, sorry, 35, 61. What is the next number in the series? 5, 6, 10, 19, 35, 61. 5 to 6, what is the difference is? 1. 6 to 10, the difference is 4. 10 to 19, difference is 9. 19 to 35, difference is 16. 35 to 61, sorry, it is 60. 35 to 60, difference is 25. What are these numbers? 1, 4, 9, 16, 25. Perfect squares. Squares of which numbers? 1 square, 2 square, 3 square, 4 square, 5 square. Again, here comes the pattern. 1, 2, 3, 4, 5 or consecutive natural numbers again. So the difference can be directly natural, even, odd, prime, composite numbers, or the difference can be squares of natural number, even number, odd number, prime number, composite numbers, and non-prime numbers. Here it is a sample example. Difference is with the squares. Now, similarly, the difference may be also possible with cubes. Okay, or the difference may be a constant number. Difference, either they have to give in among these patterns, including squares and cubes, or the difference can also be in a constant pattern. What do I mean by constant pattern? I'll tell you that. 10, 16, 22, 28, 34. One number to the next number, difference is same. 6, 6, 6, 6, 6. It is not following any pattern, just it is 6. So what is the next number will be? 6. 34 plus 6, 40. But here it comes the pattern. Natural numbers, odd numbers, even number, prime number, composite numbers, and non-prime numbers. Or the difference can be cubes of natural numbers, cubes of even numbers, odd numbers, prime numbers, composite numbers. Or the difference may be constant. Ultimately, how are we going to identify the given one is of difference logic? It's quite simple. One number to the next number, there will be a small jump. Numbers will be increasing gradually. In 99% cases, it will happen same. There will be a small jump from one number to the another number. Okay, it is about a difference logic. Now let me move to the next logic. Product logic. Now third one is product logic. When are we going to apply product logic? It's simple. It is quite opposite to the second one. Quite opposite to the second one. Now let me take an example. 2, 2, 4, 12, 48, 240. What is the next number in the series? Now, here the numbers are in an increasing pattern. Numbers are in increasing pattern, but one number to the another number, there is a big jump. Generally, we see last two numbers. We observe last two numbers or last three numbers. From here to here, 12 to 48 and 48 to 240, there is a big jump. So numbers are increasing rapidly. Numbers are increasing rapidly. If the numbers are increasing rapidly, we can apply the product logic. If the numbers are increasing rapidly, we can apply the product logic. No, by which numbers it is getting multiplying? Let's check it. 2 ones are 2, 2 twos are 4. It goes exactly 2 times. 4 and 12, it goes exactly 3 times. 12 and 48, 4 times. 48 and 240, 5 times. Again, here comes the pattern. What are these numbers? 1, 2, 3, 4, 5 natural numbers. What is after 5 is 6. So 240 into 6, 1440 consecutive natural numbers. So the product may happen with consecutive odd numbers, even numbers, prime numbers, composite numbers, non-prime numbers. Or the product may happen with squares of natural numbers, squares of odd numbers, squares of even, squares of prime, squares of composite, squares of non-composite. Right. So ultimately the important thing here is you need to understand that given numbers are increasing rapidly. So uh, what in what way you can understand or one what way you can identify that numbers are increasing rapidly means just observe the last three numbers. If it is an increasing pattern, observe the last three numbers. If there is a big jump, if there is a big jump from one number to the next number, you can say that it is increasing rapidly. Okay, so it is third logic, product logic. Now let's see the next one. Difference and product logic together. Difference and product logic applied together. Now here comes two different models. Difference and product applied alternately. Difference and product applied together. Let me give you two examples to give the clarity. Let us take an example. 3, 4, 10, 33, 136. What is the next number in the series? By looking at these numbers, definitely you will be able to say numbers are increasing rapidly. Numbers are increasing rapidly because by observing 33 and 136, you can say that there is a big jump. There is a big jump. 33 and 136, there is a big jump. So numbers are increasing rapidly. Or in another way also you can say increasing rapidly. If you can multiply from last but one number to the last number, last but one number to the last number, if you can multiply the minimum two times, if it goes minimum two times, then you can say that it is increasing rapidly. You can apply that logic also. You can apply that logic also. Okay, 33, 136. So by observing this, you can say that it is more than two times. So it is increasing rapidly. It goes maximum how many times? Four times. 33 4 is 132. But what is the number given here? 136. How much it is more than that by? 4 into 4 plus 4. Now 10 and 33. It goes maximum how many times? 3 times. It goes maximum 3 times into 3 plus 3. 4 and 10. It goes maximum how many times? 2 times. 4 to the 8 plus 2. 3 and 4 it goes maximum one time into 1 plus 1. Here comes difference and product logic applied together. In combination it is applied. Into 1 plus 1, into 2 plus 2, into 3 plus 3, into 4 plus 4. Again here comes the pattern. With which numbers we are multiplying? 1, 2, 3, 4. What are these numbers again? Natural numbers. What is the next natural number after 4? 5. So our answer will be into 5. And with which number we are adding? In plus 1, 2, 3, 4. What are these numbers? 1, 2, 3, 4. Again here comes the pattern. Natural numbers. So after 4 natural number is 5. Into 5 plus 5. So 136 5, the 680 plus 5 is 685. Here comes. So here the numbers which we are multiplying are natural numbers. It could be odd numbers, even numbers, prime numbers, composite numbers, any combination. The numbers which we are adding are natural numbers. It could be odd number, even number, prime number, composite number, anything is possible. The ultimate thing is you need to understand that the given pattern is of difference and product applied together. Simple. Numbers are increasing rapidly, you will be checking for product logic. If number not going exact number of times, you will be cross checking maximum it goes how many times and how much it is more or less than that number by. Then you will identify the pattern in the reverse order. Better, I always suggest you to identify the pattern in the reverse order. Okay. So difference and product logic applied together. There is a one more model, difference and product applied alternately. Let me give you that example. 5, 10, 13, 52, 57. What is the next number in the series? 5, 10, 13, 52, 57. If you observe 52 to 57, you can say that there is a small jump. There is a small jump. So increasing by 5. Increasing by 5. But when you observe 13 and 52, it is a very big jump. So it is multiplied by 4 times. It goes exactly 4 times. 13 4 is 52. 10 and 13 again it is increasing slowly. So 3 times. 5 and 10 it goes exactly 2 times. Again see here into 2 plus 3 into 4 plus 5. Alternately product logic is applied and alternately difference logic is applied. Here is what I call difference and product applied alternately. So again here comes the pattern. 2, 3, 4, 5. What are these numbers? Consecutive natural numbers. 2, 3, 4, 5 consecutively comes only in natural numbers, not anywhere. So 2, 3, 4, 5. What is the next number will be? 6. Multiplication, addition, multiplication, addition. Next will be multiplication. 56 is 300, 76 is 42. 342 will be here answer. So these are the two patterns which possible in difference and product logic. Difference and product applied together. Difference and product applied alternately. Alternately. Okay. Now move to the next logic. So understand how the questions will be prepared. If you have that clear idea, that clear picture, when you see the new question, it will be very easy to answer. Now the next pattern is powers logic, which is very important. Powers logic. I'll give you one sample example. 0, 6, 24, 60, 120. What is the next number in the series? What is the next number in the series? 0, 6, 24, 60, 120. 0 can be repeated as 1 cube minus 1, 6, 2 cube minus 2, 24, 3 cube minus 3. Here comes the importance of powers. 60 can be written as 4 cube minus 4. 120 can be written as 5 cube minus 5. 1, 2, 3, 4, 5. These are consecutive natural numbers. Next will be 6. According to this pattern, it will be 6 cube minus 6. 216 minus 6, 210 will be your answer. Not only this particular logic, there are multiple logics possible here. N square plus or minus n, where n can be natural number, odd number, even number, prime number, composite number. N cube plus or minus n. In recent exams, these logics become little bit popular. out of 5 questions, one question at least they are giving of this pattern: n square plus or minus n cube plus or minus n pattern. Now where n can be natural, odd, even, prime, composite. Not only this, they are also giving this pattern n square plus or minus k, where k is some constant. Earlier in both the cases n is same, but here n is different, k value is different. N cube plus or minus k. These are the logics that comes under powers. So these logics are very, very important in powers logic. N square plus or minus n cube plus or minus n square plus or minus k, n cube plus or minus k. To recognize these numbers, what I suggest you is, when you're by heart, when anyway you're going to by heart the squares and cubes, right? So try to recognize the numbers which are close to squares and close to cubes. Then your job is done. Just try to recognize the numbers which are close to squares and close to cubes. Get that idea. Once you get that idea, this logic will be very, very easy. This powers logic. Anyway, you are going to by heart the squares and cubes. So try to recognize the numbers which are close to squares and cubes. Then here comes n square plus or minus n cube plus or minus n square plus or minus k, n cube plus or minus k logics. Easily you can recognize the numbers. When you see the 24, you should try to recognize that it is closest to 5 square and closest to 3 cube. Or when you see the 60, you should try to recognize that it is closest to 8 square and closest to 4 cube. When you see 120, you should try to recognize that it is closest to 11 square and closest to 5 cube. If you can recognize that numbers, if you can recognize the numbers in this way, then identification of logics will be very, very easy. So all this you have to do before going to the exam. All this has to be done before going to the exam, this homework. Okay. And out of the 5 questions, 1 or 2 questions, minimum 1 question will be of powers logic or squares and cubes logic. Okay. Now let's move to the next model. I hope you are clear with the first 5 logics. Let's move to the next logic. Digit logic. It is one of the important question. Okay. Let me give you an example. You'll get the clarity. What is the next number in the series? The same example I have also taken in, in practice questions also. Same example. It comes under the digit logic, right? 16, 23, 28, 38, 49. What is the next number in the series? Can anyone can give you the logic? Guess the answer. Guess the answer. 16, 23, 28, 38, 49. Anyone? 16, 23, 28. Oh, received the answers. Here you can type the answer in chat box. You can type your answer in chat box. I can see the chat box. No, 57 is not the correct answer. Shreyansh, it's not 57. Okay, I will tell you, don't worry. Digit logic means here the digits given in the numbers will plays the main role. Digits in the number will plays the main role. I'll tell you that. What exactly I meant for. Right. What is the difference here? 16 and 23? 7. 23 and 28? 5. 28, 38? 10. 38, 49? 11. Right. 7, 5, 10, 11. What are these numbers? It's very simple. 7 is sum of 1 and 6. 1 plus 6. The given number is 16. Digits are 1 and 6. So 1 plus 6 is 7. And here the difference is 5, which is sum of the digits in the number 23. 2 plus 3 is equal to 5. And here the difference is 10, which is 2 plus 8 is equal to 10. In the number 28, the digits are 2 and 8. And in the number 38, digits are 3 and 8. 3 plus 8. And in the 38 and 49, 3, 49, and to find the next number, sum of the digits are 4 plus 9, which is equal to 13. So 49 plus 13 is equal to 62. It is your answer, 62. This is called digit logic. Yes, Ramya, your answer is correct. Aurora, your answer is also correct. This is what we call it as digit logic. Digits plays the role in answering the questions. Digits in the number. Not only sum of the digits, it could be also possible with difference of the digits. It is also possible with squares of the digits. Anything is possible. But ultimately, digit logic, in recent exams, they are giving these logics. Digit logics also in recent exams. Sum of the digits is the difference. No. Now, one more important model is a difference of difference. It's similar to this logic, second logic, but difference of difference. Let me give you an example, you'll get the idea. What is the next number in the series? 40, 45, 52, 62, 77. 40 and 45 difference is 5. 45 and 52 difference is 7. 52 and 62 difference is 10. 62 and 77 difference is 15. The difference 5, 7, 10, 15 does not come under any of these patterns. When you take a difference, that should definitely it should comes under one pattern. It has to come under one of these pattern: natural, odd, even, prime, composite, or not consecutive odd, I mean alternate odd, alternate even, alternate prime. That has to comes under that pattern, or the number should be constant numbers. It is not happening. That is not happening here. So what could be that? Now here you need to check difference of difference. When first difference is not in the pattern, you need to check for the second difference. 5 and 7 plus 2, 7 and 10 plus 3, 10 and 15 plus 5. So plus 2 plus 3 plus 5. What is this pattern comes under? Plus 2 plus 3 plus 5 consecutive prime numbers. So after prime number 5 is what? 7. So 15 plus 7, 22. So 77 plus 22, 99 will be your answer. Right. So this is what we call it as difference of difference. So second stage also we need to check difference of difference. First stage you won't find any proper pattern. Then go for the second stage. There you may see the proper pattern. Okay. So here are the 7 different models that they're giving in recent exams, but it is not the exhaustive list of logics. There can be some other models possible. There can be some other logics are also possible. Okay. Now let's move to the questions to solve. Let's move to the questions to solve. First, we'll discuss missing number or next number, finding the next number in the series. Because in prelims, you will be given difference or finding the next number in the series. or missing number in the series, or you may also give you given wrong number in the series. Both the models will discuss. Okay. Now let's try to answer this question. 97, 83, 73, 67, 59. For every question I will give you 30 seconds time. For every question I will give you 30 seconds time. Once you get the answer, type it in the chat box. Right, Karneshwar, your answer is absolutely right. Answer is 47. And here comes the logic. 97, 83, 89 is missing. First of all, 97, 83, 73, 67, 59 are prime numbers. You have to recognize these numbers. These numbers are prime numbers. 97 and 83, 89 is missing. So what you can say that prime numbers are given in decreasing order, but not consecutive prime numbers. Alternate prime numbers are given. 83 and 73, which number is missing? 79 is missing. 79 is missing. For 97 and 83, 89 is missing. For 83 and 73, 79 is missing. For 73 and 67, 71 is missing. For 67 and 59, 61 is missing. So what will be the next prime number? Alternate prime number they are taking. Alternate prime numbers they are taking. What is the next prime number before 59? 53 is the prime number, right? So it's we have to take the alternate number. So what will be the previous number? 47. So 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Right. So what is the prime number? Required one? 47. Alternate prime numbers. What is the logic is? Alternate prime numbers in decreasing order. Alternate prime numbers in decreasing order. Right. Let's move to the next question. Now, before going to the questions, I would like to ask one question. Are you understood that how the questions will be formed, how the questions will be generated? Have you understood the concept as of now what we have discussed? Please type in the chat box yes, no. If no, I will try to tell in a better way. All right. Thank you. Now let's move to the questions. Now, here is the second question on your screen. Now try to answer this question. 7, 11, 20, 36, 61, blank 146. Right? Vaidya and Shreyansh, your answers are absolutely right. And the correct answer is 97. So what is the logic here? Simple. 7 and 11. 7 and 11 plus 4. 11 and 20 plus 9. 20 and 36 plus 16. 36 and 61 plus 25. What are these numbers? Are you able to recognize these numbers? 4, 9, 16, 25. Squares of natural numbers. 2 square, 3 square, 4 square, 5 square. So what will be next? 6 square. And then after identifying the missing one, you need to cross check it. So it should be 36. It should be 49. 6 square and 7 square. Consecutive natural numbers. Now always and always remember that every question will follow our pattern. Natural, odd, even, prime, composite. So 61 plus 36, 97. 97 plus 49, 146. Perfectly matching. So what is the missing number in the series is 97, right? Now move to the next question. 6, 24, 60, 120, 210. 6, 24, 60, 120, 210. Anyone? Even when we are discussing the basic examples also, I have taken one of this example. Very good, Aradhana and Aguilar Hassan. Right? Devi, it is absolutely right. Now, here comes the logic. 6, we can represent it as a what? 2 cube minus 2. 24, 3 cube minus 3. 60, 4 cube minus 4. 120, 5 cube minus 5. 210, 6 cube minus 6. And next will be 7 cube minus 7. So 7 cube is 343 minus 7, 336. See, in the exam when they give all 5 questions, don't expect that all 5 they will give you difficulty. 1 or 2 questions they will give you easy only. Okay. So what is the logic is? N cube minus n, where n is a natural number. 2, 3, 4, 5, 6, 7 consecutive natural numbers. Okay. Right. Now move to the next question. Right. You try it. This is one of the memory based question which was given recently in clerical prelim. No. No, Kushar Gupta, your answer is wrong. It's not 25. Check it again. No, Keshav, your answer is wrong. It's not 365. Even it is not 225, Shrey, Aurora. No, it's not 225. In a hurry, please don't commit mistakes. It is important. Yes, Ashish Patel, your answer is absolutely right. And Aurora, your answer is also right. 65. Now, here comes the logic. What is the logic? It's quite simple. 750, 250, it is exactly, first of all, you can understand that numbers are given in decreasing pattern and are decreasing rapidly. When it is increasing rapidly, we'll check for the product. If it is decreasing rapidly, we will be checking for division logic. That's it. It is divided by 3. 750 75 divided by 3 is 25025. 25025 divided by 5 is 5005. 5005 divided by 7. Or else, if you observe in the reverse order, it is into 7. 715 into 7. 707 is 4900. 15 sevens are 105. Together 5005. Perfectly matching. So divide by 7. What are these numbers? 357 could be prime numbers, could be odd numbers. You cannot confirm that. Right. 357 next may be following the 11 or next may be following the 9. If it follows 9, Next, it must follow 11, right? According to the missing number. Or else, what is another logic? It can follow 11 and next it will follow 13. So we need to verify that. We need to verify that which is the correct pattern. If it goes in this way, it is odd number pattern. If it goes in this way, it is prime number pattern. So whether it is odd number pattern or prime number pattern, let's check it. Divide by 3, divide by 5, divide by 7 is confirmed. Now, 715 divided by 9. 715 divided by 9. Either 715 is divided by 9. Let's check it. 9 it goes maximum how many times? 6, 7 times. 9 7 is 63. What is the remainder? 8, 85. So 9 it is not exact multiple. So it is not this pattern. So odd number rule pattern is ruled out. So it must be divided by 11. 11 goes maximum how many times? 6 times. 11 6 is 66. And what is the remainder obtained there? 5. So 55. So it goes how many times? 5 times. So 65. So 715 divided by 11 is 65 and 65 divided by 13. According to that, next prime number is 13. So 65 divided by 13 is 5. Perfectly matching. Perfectly matching. So what is the missing number in the series is 65. Yesterday, I explained with divide by 9 also. Have you checked that? It could be divided by 9 or it could be divided by 11. We cannot confirm that. It can be odd number series or it can be prime number series. If it is divided by 9, I should get exact, I should get integer, but I am unable to get the integer there, right? So that's why it cannot be odd number pattern. So it has to be prime number pattern. I hope it is clear to everyone. Now let's move to the next question. Right. Now it is also one of the important logic. 12, 6, 6, 9, 18, 45. Try it once. 12, 6, 6, 9, 18, 45. I may not be giving more time. Right. 135 is absolutely right. Into 3. Right. Let's check the logic. 12 and 6. 12 to 6. It goes maximum how many times? 0.5 times. 6 and 6. 1 time. 6 and 9. 1.5 times. 9 and 8. 2 times. 0.5. 1. 1.5. 2. And every time it is getting increasing by how much? 0.5. 0.5. So next will be 2.5. So 18 into 2.5, 18 to the 38 and half of the 18 is 9. So 36 plus 9, 45. Perfectly matching. So what will be next? 3. So 45 into 3 is 135. So required number is 135. So logic is into 0.5, into 1, into 1.5, into 2, into 2.5 and into 3. Right? Now move to the next question. Right. Try this question. 12, 35, 106, 370, 952. Yes, Minu Pierce, your answer is absolutely right. 2855. Right. Now let's check the numbers. 370, 952. By seeing these numbers, you can say that numbers are increasing rapidly. So we need to apply the product. 370, 952. Is it goes exact number of times? Let's check it. 316 maximum goes in 900 3 times. 317 3s are 951. But this number is 952. So you can represent this number as into 3 plus 1. Into 3 plus 1. 106 317. It goes maximum 3 times. But 106 3s are 318. So you can write this number in the form of into 3 minus 1. 35 and 106, it goes again 3 times. 35 3 is a 105, but it is 106. So into 3 plus 1. 12 and 35. By observing the above pattern, you can say that it is into 3 minus 1. 12 3 is a 36 minus 1. So into 3 minus 1, into 3 plus 1, into 3 minus 1, into 3 plus 1. So alternately into 3 minus 1, alternately into 3 plus 1. So 952 into 3s. 903 is a 2700. 53 is a 150. So 2850, 6. 2856 minus 1, 2855. So required answer is 2855. Choice 2. Next. Move to the next question. No. Try this one. 5, 13, 41, 85, 257. Yes, Shreyansh, your answer is absolutely right. It is 517. No, Ashish, it is not 773. It is 517. Correct answer is 517. Right. Let's check it. 85 and 257. It goes maximum 3 times. It goes maximum 3 times. 85 3s are 255. But it is more than that by how much? 2. So into 3 plus 2. 41 and 85. 41 and 85. It goes maximum how many times? 2 times. 41 to the 82. But it is more than that by 3. Into 2 plus 3. 1341 goes maximum 3 times. 13 3 is a 39 plus 2 into 3 plus 2. Can you observe the pattern? Into 3 plus 2 into 3 plus 2. But here it is into 2 plus 3. Okay. 5 and 13. 5 to the 10 plus 3 13. It is perfectly matching with this logic. So alternately into 2 plus 3, alternately into 3 plus 2. So what will be next? Into 2 plus 3. If you do into 3 plus 2, you will get the wrong answer. Right. So 257 2s are how much? 514 plus 3, 517. Choice 5. So these are all the memory based questions from the various exams. Different patterns of questions are taken. Here comes the next question. Right. Answer this question. 2, 4, 7, 35, 42, 462. Yes, Kushagra Gupta, you need to practice a lot. You should be in the stage to recognize the numbers. You need to practice a lot. Right. Your answers are correct. This comes under difference and product applied alternately. Now see here 2 and 4 multiplied by 2, 4 and 7 plus 3, 7 and 35 into 2, 35 and 42 plus 7. What are these numbers? 2, 3, 5, 7 consecutive prime numbers. So next will be 11. 42 11s are 462, perfectly matching. So what is the next prime number after 11? 13. So 462 plus 13 is 475. Choice 4. Choice 4. Next, ninth one. Right, Anamika, your answer is absolutely right. 196 is the correct answer. 196 is the correct answer. Even Devi, your answer is right. 196. It's simple. 5 plus 12 is equal to 17. 12 plus 17 is equal to 29. Sum of the two consecutive numbers is the next number. 17 plus 29 is equal to 46. 46 plus 29 is equal to 75. 75 plus 46 is equal to 121. So 121 plus 75 is equal to 196. 75 plus 121 equal to 196. Sum of these two numbers is equal to the next number. Fibonacci series. 5 plus 12 17, 12 plus 17 29, 17 plus 29 46, 29 plus 46 75, 75 plus 121 196. And this question number 10 we already discussed as a part of a basics digit logic. I hope you remember that. Same numbers, same example I taken. Okay, 7, 5, 10, 11. 7 is sum of 1 and 6. 5 is sum of 2 and 3. 10 is sum of 2 and 8. 11 is sum of 3 and 8. So next is sum of 4 and 9. That is 13. So 49 plus 13, 62. So again, I'm not discussing in detail. We already discussed that. Right? Now, so far what we have discussed, those are of missing number or finding the next number. Now let's move to the wrong number series. Now here onwards there will be a slight increase in the level of difficulty of the questions. Right. We'll discuss the questions together. Okay, we don't have much time. We'll discuss together. 6, 18, 21, 60, 66, 198, 201. Right. Here you need to find out the wrong number. So a sequence of numbers will be given which follows a definite pattern. Somewhere else it breaks the pattern. The number which breaks the pattern will be a wrong number in the series. Let's check it. 198 and 201, it is plus 3. 66 and 198, it is exactly multiple 3 times. And 60 and 66 plus 6. 2160, it is not exact multiple. But 6 and 18, exactly 3 times. 6 3 is 18. 18 and 21 plus 3. Now observe the pattern. Into 3 plus 3 into 3 plus 3, and you know there will be a one wrong number in the series. By correcting that, it will follow a proper pattern. Now let us try to apply the same logic. Into 3 plus 3 into 3 plus 3. If I again do the into 3, 21 3 is a 63. So 60 should be replaced by 63. When 60 replaced by 63, after into 3, it should be what? Plus 3. So 63 plus 3, 66, perfectly matching. So what is the wrong number in the series? 63. Sorry, 60. Choice 3 is your answer. 60 is the wrong number in the series. And the logic is into 3 plus 3. And the correct number is 63. Right? Move to the next question. No. 7, 8, 20, 43, 107, 232, 448. Let's check it. 7 and 8, but the difference is 1. Okay. 232, and here the difference is 12. Okay. And here the difference is 23. But 43 and 107 difference is 64. 107 and 232 difference is 125. 232 and 448 difference is 216. Are you able to recognize these numbers? 64, 125, 216. Yes, perfect cubes. 64 is 4 cube, 125 is 5 cube, 216 is 6 cube, and 1 is 1 cube. What are the missing cubes? 1, 2 numbers are missing, 4, 5, 6. Definitely missing numbers will be 2 and 3. And the logic applied is cubes. 2 cube is 8. So 2 cube is 8. So 8 plus 8 should be 16. So 20 should be replaced by 16. And 3 cube is 27. 16 plus 27 is 43, perfectly matching. So what is the wrong number in the series? 20. Difference is the perfect cubes. Difference is the perfect cubes. Okay. Now move to the next question. 5, 8, 15, 26, 15, 98, 194. What is the next number in the series? 98 and 194. We can multiply minimum 2 times. 98 to the how much? 196. But what is this number is 194. You can represent this number as into 2 minus 2. 50 and 98, again you can represent them as into 2 minus 2. 26 and 50, you can write them as into 2 minus 2. 26 to the 52 minus 2. 15 and 26, here comes the problem. It is into 2 minus 4. 8 and 15, into 2 minus 1. But again 5 and 8, into 2 minus 2. 5 to the 10 minus 2, 8. But observe the pattern. Into 2 minus 2, into 2 minus 2, into 2 minus 2, into 2 minus 2. We may go ahead with the logic of into 2 minus 2. Right, because every time it is going maximum 2 times only. But everywhere it is minus 2, except in these two numbers. And definitely there will be a one wrong number. By correcting that, it will follow the pattern. Now let's check it. Into 2 minus 2 here. So 8 to the 16 minus 2, 14. So 15 replaced by 14. Now 14 to the 28 or minus 2 is 26. Perfectly matching. So what is the wrong number in the series is 15. That is choice 1. Wrong number in the series is choice 1. And the logic applied is into 2 minus 2. Yeah, Keshav, we have so many questions to discuss. You will be getting that kind of series. Don't worry. Okay. Now, let's answer the question number 14. I mean, let's try it once. You will be given larger numbers also, but don't be fear of looking at the larger numbers. When they give the larger numbers, it is simply product logic. It's simply product logic. That's it. 13, 550, 16, 25, 28. It is in 10,000s, it is in lakhs. But 13,550, 1,62,528, it goes maximum 11 times, not more than that. Because 13,550 10 times is 1,35,550. Right. One more 500. 1,35,500. One more 13,550 if you add, you may be getting 1,62,000 only. Right. Not more than that, right? So maximum it can be multiplied how many times? 3 times, sorry, 11 times. Let's check it. Or 13 times. Let 12 times. Let's check it. 13,550 10 times is 13,5500. I'm multiplying for 2 more times. Let's check it. 13,550 2 times is how much? 26,000, 27,100. 27,100. So totally how much? 0,06261. 1,62,600. What is this number? 1,62,528. It goes maximum 12 times, but not exactly 12 times. So how much it is less than that number by? How much it is less than that number by? It is exactly less than that number by how much? 72. Okay. It is exactly less than that number by 72. Now 1360, 13,550. It goes maximum 10 times. Maximum 10 times. 13,600. And how much it is? 50 into 10 minus 50. Now look at the numbers. Into 12 into 10. If you consider this as an even number series, if you consider this as an even number series, it goes maximum 8 times. It goes maximum 8 times. 100, 174 8 za. 174 8 za. 8 4 the 32, 3, 7 8 the 56, 9, 5, 8 1 the 8 plus 5, 13. 1392. 1392. 174 8 the 1392. But what is the number given? 1360. So how much it is less than that by? 32 into 8 minus 32. Look at the pattern. Into 8, into 10, into 12. Perfectly matching with the even numbers. So what should be the previous one? Into 6. And the previous one is into 4. So 10 4 is a 40. And it is less than that by how much? 8. 32 6 are. 36 are 180. 2 6 are 12. 192. It is less than that by how much? 18. 192 minus 18 is 174. 32 6 are how much? 192. Minus 18, 174. Into 4, into 6, into 8, into 10, into 12. These are okay. But what are these numbers? The numbers which we are subtracting. Into 8, into 18, into 32, into 50, into 72. Is it following any proper pattern? No. So let's check the difference of the difference. I already discussed. When first stage is not in a proper way, you need to check the second step. 8 and 18, what is the difference is? 10. 8 and 32 difference is how much? 14. 32 and 50, what is the difference? 18. 10, 14, 18. So what is that? Plus 4, plus 4, plus 4, plus 4. So what should be next? Plus 4. 18 plus 4, 22. So 50 plus 22, 72. Perfectly matching. Nothing wrong in that. Okay. So there is some small correction required. Let us consider this as a 16,530. Let us consider this as a 16,530. Make a small correction. So this will be 70, but actually required is what? 72. So by correcting this, you will get 1,62,528. Let's make a small correction. Okay. There is no such wrong number here as of now. So let's make a small correction. And I hope you are clear with the pattern. So numbers which we are multiplying are into 4, into 6, into 8, into 10, into 12. And the numbers which we are subtracting are not properly given in the first stage. So we are checking the difference of the difference. And the difference of the difference is 10, 14, 18, 22, which is nothing but plus 4, plus 4, plus 4. So if you want to find the next number, 22 plus 4, 26 you go to. Okay? No. Let's move to the next question. Right. Now let's try to answer this question once. 40,000, 10,500, 2,500, 625. If you look at these numbers, you may get some idea. 2,500, 625 exactly divided by 4. Even this is close to divided by 4. 40,000 divided by 4 is 10,000. If you correct this, you will get 10,000. But it has to follow the pattern, right? 10,000 divided by 4, 2,500. Perfectly matching. What is the wrong number? 10,500. It's very simple. 10,500 is the wrong number. 625 divided by 4 is 156.25. 156.25 divided by 4 is 39.0625. Perfectly matching. So here they given the clue. 2,500, 625 for easy understanding. Divided by 4. And this is close to 4 times, even this is close to 4 times. So we corrected the number 10,500 to 10,000, and it is following a proper pattern, right? Now move to the next question. Right. 2, 10, 30, 68, 140, 222. What are these numbers? 2, 10, 38, 60, 140, 222. When we're discussing the basics, I already told you, not only squares and cubes, you should try to recognize the numbers which are close to squares and close to cubes. 222 is 15 cube minus 3 or 6 cube plus 6. 140 is 12 square minus 4. 68 is 8 square plus 4 or 4 cube plus 4. 30 is 5 square plus 5 or 3 cube plus 3. 10 is 3 square plus 1 or 2 cube plus 2. 1 is, so 2 is 1 square plus 1 or 1 cube plus 1. Which seems the proper one? And there will be one wrong number. Which seems the proper one? Squares are not in a proper pattern. Squares are not in a proper pattern, but the cubes are in a proper pattern. 1 cube plus 1, 2 cube plus 2, 3 cube plus 3, 4 cube plus 4, 6 cube plus 6. What is the missing one? 1, 2, 3, 4, blank 6. Consecutive natural numbers. So 5 cube plus 5. So 5 cube plus 5. 5 cube is 125 plus 5, 130. So what is the missing wrong number? 140. And what is the correct number? 130. So choice 4. This powers logic is very important. Now recent days they are giving this kind of logics, power logics. Okay. Now move to the next question. 1, 2, 8, 33, 148, 740. Now definitely we can say that numbers are increasing rapidly. There is a rapid growth from one number to the next number. 148 and 740. It goes maximum how many times? 5 times, not more than that. What is 145? What is 145? And you know, definitely there will be one wrong number. 148 5 exactly 740. It is exactly 5 times. It goes exactly 5 times. Okay, fine. 33 148. It goes maximum how many times? 4 times. 33 fourths. 132. But it is more than that by how much? 16. So into 4 plus 16. Here it is exactly 5 times, but it is into 4 plus 16. Okay. And it is 4 times and it is 5 times. So what could be the previous one? Maximum 3 times. Okay, let's check it. 8 3 is 24 plus 9. 8 3 is 24 plus 9. Or you can say that 8 4 is 32 plus 1. Let's find it, which is the proper pattern. 2 and 8. Into 3, into 4, into 5. Now we can say that into 2 plus 4. Into 2 plus 4. Into 2 plus 4. Right. Now 1 and 2 you can say into 1 plus 1. What are these numbers? Can you able to recognize? Into 1 plus 1, into 2 plus 4, into 3 plus 9, into 4 plus 16. 1, 4, 9, 16 are squares. 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square. So what it is? Into n plus n square. Into n plus n square. So what will be the next number? What is the wrong number? Everywhere it is following the logic of into n plus n square except in the last number. So what is last number? Just it is into 5. We should also add what? 5 square, which is 25. So 148 5 is a 740 plus 25 is 765. So correct number is 765 and wrong number is 740. That is choice 3. Okay. Now we are moving to the advanced models, mains level of difficulty questions. Okay. Not with this question, with the next question onwards. 6, 54, 34, 238, 218, 1070, 180. Oh, sorry, 1080, 1070. Close numbers, close numbers, close numbers, and increasing rapidly, increasing rapidly, increasing rapidly. So what you can say that alternately increasing rapidly, alternately decreasing rapidly. Let's see, 54, 34 minus 20, 238, 218 minus 20. So minus 20 minus 20. So what should be it is? If it is minus 20, this could be 1090, or if it is wrong number, it can be 1060. We don't know which is correct, which is wrong. Let's check the pattern. Right. 654 it goes maximum how many times? 9 times. 6 and 54 it goes maximum how many times? 9 times. 34 and 238 it goes maximum 7 times. 37 the 210, 7 for the 28, 238 maximum 9 times. 218 1080 maximum 5 times. What is 218 5 the? 205 the 1000, 18 5 the 90. So 1090 is the correct number. So what is the wrong number in the series? 1080. 1080 is wrong number, 1090 is correct number. So what is the next number will be? 1070, perfectly matching after subtracting 20. 1090 minus 20 is 1070. So alternately multiplying and alternately subtracted by 20. The numbers which you are multiplying are odd numbers in decreasing order, 975. Now, next question onwards, we are discussing the mains level of difficulty questions. Very few examples I have taken. Right. Here is the question. 24, 36, 46, 61, 81, 108. So first read the instructions. In the following question, a number series is given. After the series, a number is given, followed by some blank spaces. You have to complete the series starting with the number given. You have to complete the series starting with the number given, that is 32. Following the same logic as that of original series. So in the original series, whatever the logic is applied, we need to apply the same logic here. Right. So first we need to identify the logic in the original series. What is the logic here? It is increasing slowly, increasing gradually. So we need to check the difference. So 24 plus 10, 34 46 plus 12, 46 61 plus 15, 61 81 plus 20, 81 108 plus 27, 10 12 15 20 27. Can you able to recognize these numbers 10 12 15 20 27? Can you see any proper pattern here? 10 12 15 20 27? No. It is not consecutive, natural, even odd, prime, composite. It is not that kind of pattern. Even it is not square, not cubes. So go for the next difference. What is the next difference? Plus 2, plus 3, plus 5, plus 7. Consecutive prime numbers. Difference of difference is what? Consecutive prime numbers. So starting from 32, we need to apply the same logic. So what should be first? Plus 10. So 32 plus 10, 42. And what will be next? Plus 12. Same logic. Plus 10, plus 2, plus 15, plus 20, plus 27. When we are applying this logic, which implies that we are also taking the difference as a what? Consecutive prime numbers. So not an issue. So 42 plus 12, 54. But what is the question asked? Which number takes the place of question mark? So in the fourth place, we need to find. So plus 10 plus 12, next will be plus 15. So 54 plus 15, 69. So your answer is 69. Choice 2. So here the logic is difference of difference. And this kind of questions are of mains pattern. You may be given a different logic, but the pattern of the question is mains. Now move to the next question. 2, 6, 15, 80 and so on in a series. If 6094 is the nth term in the series, then find the value of n. Okay. Here we have given nth term in the series is 6094. We have to find this, what is n. So we have to identify the logic till you get the number 6094. So what is the pattern here? 15 and 80 into 5 plus 5. 15 5 is a 75 plus 5 80. 6 and 15 into 3 minus 3. 6 3 is a 18 minus 3 15. 2 and 6 into 2 plus 2 into 2 plus 2. What are the numbers that we are taking with for multiplication? 2 3 5. Where we get 2 3 5 consecutively? Prime numbers. So after 5 prime number is 7, and after that prime number is 11. Okay. The numbers which we are adding are plus 2 minus 3 plus 5. Numbers are consecutive prime numbers, but one time we are doing addition, one time we are doing subtraction. So plus 2 minus 3 plus 5 minus 7 plus 11. Let's check it. What is 87? 560. 560 minus 7, 553. 553. What is 553 into 11? Let's check it. 553, 553 tens are 5530. And one more time is 553. So 3806, 6083. 6083 plus 11, perfectly matching with the given number 6094. So what is this number? Which term it is? 1, 2, 3, 4, 5, 6. Nth term, which is sixth term in the series. So n is equal to 6. Choice 1. N is 6. And the logic is into 2 plus 2 into 3 minus 3 into 5 plus 5 into 7 minus 7 into 11 plus 11. Prime numbers logic, where difference and product applied together, alternately addition and alternately subtraction. Move to the next question. Here comes the multiple series. Two series 1 and 2 are given below with one wrong number in the series. Identify the two wrong numbers and replace them with the correct numbers. Identify the two wrong numbers and replace them with the correct numbers. Now, we have given a series, right? Very simple. 12 and 15 plus 3. These are memory based questions, exact logic, which are given in mains. 12 plus 3, 15. 15 minus 6, 9. 9 and 18 plus 9. 18 and 16 minus 12. We have to find out the wrong number first. 6 and 23. Observe the pattern. Plus 3 minus 6 plus 9 minus 12. Next should be plus 15. 6 plus 15, 21. If you want, verify it. Next should be minus 18. 21 minus 18 is 3, perfectly matching. So in the first case, what is the wrong number? 23. Wrong number is 23 and the correct number is what? 21. Next, let's come to the second series. 13 and 14 difference is 1. 14 and 22 difference is 8. 22 34 difference is 12. 34 95 difference is 61. 95 120 difference is 25. 120 336 difference is 216. Are you able to recognize these numbers? 216, 25, 8, 1. Are you able to recognize these numbers? I am able to recognize the numbers. 216 is 6 cube. 25 is 5 square. 1 is 1 square or 1 cube. 8 is 2 cube. So observe the pattern. 1 square, 2 cube, 5 square, 6 cube. What could be the missing numbers? 3 square, 4 cube. It is our guess. 22 plus 9 is 31. 31 plus 4 cube, 64 is 95. Perfectly matching. So what is the wrong number in the series? 34. And what is the correct number? 31. Now the question is about which of the following is true about the correct numbers. After identifying the two numbers, We have to find out what is correct regarding that. The sum of these two numbers is 55. No, 21 plus 31 is 52 only. So not the first option. The average of the numbers is 28. No, 21 plus 31, 52 divided by 2 is 26. Average is 26. Not the second option. Is the product is 651? Let's check it. 21 into 31 is 651. Choice 3. 31 tens are 310. One more 10 times 310. One more time 31. It is 651. So choice 3 is perfectly matching. But there is option given more than one of the above is true. So definitely we need to check the fourth one. The difference of the two numbers is 11. 21 and 31 difference is 10. So not the fourth option. So it cannot be more than one of the above. So your answer is third option. So first we have to identify the wrong numbers, and that we have to replace with the correct numbers, and we have to find what is true regarding them. Okay, it is given very recently in the exam, clerical means. Now move to the next question. Based on the series given below, which of the statements LMN are definitely true? Series given 11, 19, 35, 67, 135, 259. You no need to find the logic here. Series is this one, and x is the nth term, and y is the n plus 1th term. Means if it is a x term, this will be y term. If x is the first term, y will be the second term. If x is the second term, y will be the third term. If x is the third term, y will be the fourth term, right? And so on. X is the nth term, y is the n plus 1th term. Now let's find out the logic here directly. If it is x, this will be y. 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 Right. If it is x, this will be y. So you can take any x and y, any x and y to find this, to find this, which among LMN is correct. We have given some expressions, right? Now let's take the smallest numbers. It will be very easy to find, right? Now, what is the first equation? What is the L equal to? Y equal to 3x minus 2. What is the y here? 19 is equal to 3 into, what is the x? 11 minus 2. 3 11s are 33 minus 2, 31. Is it equal? No. 19 not equal to 31. So L is not correct. Now we need to check the M. What is the M? Y equal to 2x plus 3. What is the y? 19. 2 into, what is the x? 11 plus 3. 2 11s are 22 plus 3, 25. So 19 is not equal to 25. Even M is not true. Let's check the N. N equal to, N is y equal to 2x minus 3. What is y? 19. 2 into x is 11 minus 3. So 2 into 11, 22 minus 3, 19. 19 is perfectly matching with 19. So only which is correct? N. Only N is correct. I hope you are clear with this pattern. Just they are asking us to find the logic. That's it. Just they are asking us to find the logic. Earlier they used to ask everywhere what is the next number or what is the wrong number. Now here directly they are asking what is the logic. What is the logic is y equal to 2x minus 3. If you want to check it, let's take the another one. Y equal to 2x minus 3, where x is 19, y is 35. Y is 35, x is 19. So 2 into 19 minus 3. 2 19 is 38 minus 3, 35. Perfectly matching, right? Because x is the nth term or y is the n plus 1th term. Any confusion in this question? Any confusion in this question? Right. Now let's move to the next question. This question also given in recent mains exam. You have given 3 series where you have to find the wrong number first in each series. Then which among the following choices is true about the relation between x and y, x, y and z? And x, y, z are the wrong numbers in the series 1, 2, and 3. Here is the x wrong number, here y is the wrong number, here z is the wrong number. So first you have to identify the wrong numbers. What are the given numbers? 10, 20, 37, 63, 110, 150, 215. Definitely if you see small increase plus 10, plus 17, and plus 26. Are you able to recognize these numbers? 10, 17, 26? I can. These are close to perfect squares. 10 is 3 square plus 1. 17 is 4 square plus 1. 26 is 5 square plus 1. And here it is 37. Next pattern, 6 square plus 1. But what is the 63 plus 37? It is 100 only. But what is the number given? 110. So 110 is the wrong number and 100 is the correct number. But next check the pattern. After 6 square plus 1, it should be 7 square plus 1. 7 square plus 1 is 50. 100 plus 50, 150, perfectly matching. Next is 8 square plus 1. 64 plus 1, 65. 150 plus 65, 215, perfectly matching. So what is the wrong number in the series? 110. What is the correct number? 100. So x is a 100. Sorry, x is a 110. X is a 110, which is the wrong number. And the correct number is 100. Okay, fine. Now move to the next one. 6, 14, 46, 191, 966, 5820. Right. Now 967, 5820. It goes maximum how many times? 5 times. 967 5s are how much? 9000 5s are 4500. 60 5s are 300. 7 5s are 35. So it is 4835. Sorry, 9 5s are 4500. So it goes maximum how many times? 6 times. So I can take 6 times also. Right. 9 6 are 5400. 66 are 360. And 7 6 are 42. So 5802. But what is the number given? 5820. So into 6 plus 18. Into 6 plus 18. Okay, let's check it. 191, 967. It goes maximum how many times? 5 times. 191 5s are how much? 955. 195 is a 950. 1 5 is a 5. So plus 12 into 5 plus 12. Now 46, 191. Maximum it goes how many times? 4 times. 160 plus 24, 184. So it is into 4 plus 7. Into 4 plus 7. 14 and 46. It goes maximum how many times? 3 times. 14 3 is a 42 plus 4. Plus 4. 6 and 14. It goes maximum how many times? 2 times. 6 to the 12 plus 2. Right. So into 2, into 3, into 4, into 5, into 6. There is no wrong with the product. So definitely you have to check the difference. What is the difference given? 2, 4, 7, 12, 18. These numbers are not following any pattern. 2, 4, 7, 12, 18. Neither prime, squares, cubes, consecutive, even, consecutive, odd. Not following that. Even alternate, it is not following that. But if you observe that 2 and 4 difference is how much? Let's just only take the difference. 2, 4, 7, 12, 18. What is the 2 and 4 difference? Difference of difference I'm checking. 2 and 4 is 2. 4 and 7, 3. 7 and 12, 5. So 2, 3, 5 are consecutive prime numbers. Next will be 7. So 12 plus 7, 19 is required difference. So it is not 18, 19 is required. When it is 19, it is not 5820, it is 5821. 5821. So what is the wrong number in the series? 5820. So y is 5820. Now let's move to the third one. What is the third series? 225 plus 3. 5 to 12 plus 7. 12 to 25 plus 13. 25 54 plus 29. Okay. 54 112 plus 58. What are these numbers? 3, 7, 13, 29, 58. 3 is the next prime number after 2. Here the given number is 2, next prime number is 3. Here the given number is 5, next prime number is 7, next prime. And the logic is next prime. Recently given this model. 12, next prime number is 13. So after 25, next prime number is 29, immediate prime number. After 54, actually the immediate prime number is 59. 59 is the prime number. So 112 is not wrong number and the correct number is 113. And the logic is next prime number to the given number. 2 next prime number is 3, 5 next prime number is 7, 12 next prime number is 13, 25 next prime number is 29, 54 next prime number is 59. So wrong number is 112 and the correct number is 113. So Z is 113. Now you know the X value 110, Y value 5820, Z value 113. So which is true? Is the Z is less than X? No. Is the Y is greater than Z? Yes, absolutely. Y is value is how much? 1113. Is greater than 5820? No. So it is not the second option. Let's check the XYZ. What is X? 110. What is Y? 5820. Yes, 1110 is less than 5820. What is Z? What is Z? Y less than Z? Is the 5820 is less than 113? No, not the third option. Now again, X is 110. Z is 113. Z is 113. No, just a moment. 113. I'm extremely sorry. Let's once check the second option. We did a small mistake in the second option. Y is 5820, right? Y is 5820 is greater than 113 is greater than 1110. So which is the correct option? Second option. Second option is perfectly matching. Y greater than Z greater than X. And what are the correct numbers? 100 in the first series, 5821 in the second series, 113 in the third series. So Z is actually 112. It is a 112 is the wrong number. I'm sorry. Okay. Anyway, you understood the pattern, I think. Now, based on the same logic, you have the next question also. It is a typical question. Now, L and M are the correct numbers to replace the wrong numbers in the series 1 and 3. Right. What are the correct numbers in 1 and 3? 113 is the correct number and 100 is the correct number. So L is 100 and M is 113. And what is given? N is equal to the larger root of the equation p square minus 7p minus equal to minus 12. Right. What is this expression will be? P square minus 7p plus 12 equal to 0. So when you solve this expression, you will get the values of p are what? 4 and 3. And what is mentioned? N is the larger root of the equation. So what is the larger root? 4. So n value is 4. So you got the L, M and N values. Now which of the following statements is definitely true? Is the L plus N greater than M? 100 plus 4 is greater than 113? No. So not the first option. Now what is this? L by N. L by N is 100 by 4 is equal to, what is the M value? 113 plus 12 by 5. 100 by 4 is 25. 113 plus 12, 125 by 5 is 25. So perfectly matching. So choice B. Next, M minus N equal to I 1 L plus 3 whole square. What is the M minus N? 113 minus 4 is 109 is equal to L is 100 plus 3 square is 9. So 109 is equal to 109, perfectly matching. So choice C. Both B and C. Choice 5 is the correct answer. So these are the recent models which they given in the number series. Okay. Now let's quickly will revise letter series. It won't take much time. Right. Let's move to the letter series. To answer the letter series questions, you have to be thorough with English alphabet and the position values of the English alphabet. Position values of the English alphabet. S place value is 19, W place value is 23, T place value is 20, X is 24, U is 21. Place values according to the English alphabet. So what is the logic? Here each group consists of 3 letters. In all letter series questions, you can follow this pattern. Each group consisting of 3 letters, right? So identify the logic in the first letters in each group. Identify the logic in the first letters in each group. 19 plus 4, 23. 23, 20 minus 3. 20 plus 24 plus 4. 24, 23 minus 3. Applying the same pattern, plus 4. 21 plus 4, 25. Your answer should start with Y. There is only one option is starting with Y. So choice 3 is your answer. In the exam, you can do up to here. It is enough. But here we'll do it. What are the second letters in each group? L, J, M, I, N. Second letters in each group. I'm taking the second letters in each group. Let's identify the logic. Write the place values. L12, J10, M13, I9, N14. Let's check the logic. Minus 2 plus 3. Minus 4 plus 5. Applying the same logic, what should be next? Minus 6. 14 minus 6 is 8, which is H. So YH perfectly matching. Let's identify the logic in the third letters. What are the third letters? W, V, T, Q, M. Let's write the position values. W is 23, V is 22, T is 20, Q is 17, M is 13. 23, 22 minus 1, 22, 20 minus 2, minus 3, minus 4. So what will be next? Minus 5. 13 minus 5, 8, which is H, Y, H, H perfectly matching. So this is how letter series questions will be answered everywhere. Everywhere you can answer in the same way. First letter to first letter in each group, second to second in each group, third to third in each group, you will get the answer. Okay? Right. Now move to the next question. It is similar to that. You try it later. We don't have much time to discuss. You try it later. I'll give you the key for the question number 26. It is choice 4. XYAD. XYAD. Okay? Now let's move to the 27. It is a different question. Previous and preview. So here we have the 8 letters. But when it comes to here, it becomes 7. Here it is 6. Here it is 5, 4, 3. So one group to the next group, one letter is missing. So you need to identify the missing pattern. So S is missing, and then P is missing, and then previous in preview PREVIO, P is missing, so remaining is REVIOU, and U is missing REVIO, and R is missing EVIO, and O is missing EVI. So first and last letters are missing always. So earlier last letter is missing, now first letter should be missed. So E is missing, so remaining is what? VI. So your answer is VI. It is a new pattern. They given in recently in SSC exams. Letter series is very important for SSC and railways. So choice 3. First and last letters are missing alternately from one group to the next group. No. This is a one more pattern they given recently in SSC. I mean, there will be only change in the one letter at a time, not in all the letters. If you observe that, HOUSE, HOUSV, only change in the last letter. What is this letter? Opposite letter. E opposite letter is V. Opposite letter is nothing but when you give the position values in the English alphabet, sum will be equal to 27. E opposite pair is V. E is 5 and V is 22. The sum is 27. So opposite pair. So only one letter is changed. Remaining all the letters are same. HOUS, HOUS. And second to third, first 3 letters and last letter remain same. Now there is a change in the second letter. Now there is a change in the second from the last. Earlier last letter, no change in the second from the last letter. Here to here, S is missing and H is replaced. So S opposite pair is H. S is 19. To get the 27, 8 is added, that is 27. So S is replaced by H. S opposite pair is H. S opposite pair is H. So last letter is missing. Second from the last letter is missing. No third from the last letter. What is the third from the last letter? U. U opposite pair is F. U opposite is F. U is 21. To get the 27, 6 should be added. 6 is F. Now previous two letters remain same. Next two letters remain same. HOV, HV. It is first option. If you want verify it, now fourth from the left, O should be changed. O should be replaced. So H remains same, FHV remains same. O opposite is L. O opposite is L. So every time one letter is replaced by opposite letters starting from the right end. Right hand first element, right hand second element, right hand third element, and so on. Each time one letter is missing. Okay. Now move to the next question. Right. This is one called sequence in gaps. How these kind of questions will be answered? It's very simple. First, we need to find different letters. How many different letters are there? How many different letters are present? Three different letters A, B, C. Total number of letters. After this, total number of letters. 90% of the questions you can complete in this pattern. Total number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 letters. Total number of different letters are 3. Total number of letters are 21. So these each with group of 3 letters, you can divide into 7 parts. 1, 2, 3, 4, 5, 6, 7 groups. Now try to replace the try to replace. I mean try to substitute the choices. It's all about substituting the choices. Okay. Now here what is missing? B, A, C. Right. Observe the pattern. A, B, C, C, B, A, A, B, C, C, B, A. Can you see any repeated sequence? Yes. What is that repeated sequence? A, B, C, C, B, A. A, B, C, C, B, A. It is following this pattern. Now, what should be next? A, B, C, C, B, A. It is also following the same pattern. A, B, C, C, B, A. So, what should be next? A, B, C. So, what is the group required? B, A, C, A, C, C, B. B, A, C, A, C, C, B. First option. When you substitute the first option, you are getting. Or the reverse approach. Different number of letters, total number of letters identification, dividing into the groups and identifying the missing ones and finding the repeated pattern. It will follows one pattern. That pattern you need to identify. Okay. And in this similar one, in the same sequence in gaps, they're recently giving meaningful words also. That is your last question here. Meaningful words. How many different letters you can see? 5 different letters. What are the 5 different letters? H, O, N, E, Y. This itself is a meaningful word. Honey, 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 honey. So let's just identify the missing letters. So this is one new model they are giving. They are giving the meaningful word. H, O, N, E, Y. 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 So what are the missing ones? O, Y, E, N, Y, E, O, Y. It is a missing one. It is available in which option? Second option. So not only ABC patterns, they are also giving the meaningful word with missing letters. Once you get the idea of that meaningful word, answering this question will be very easy. Okay. So that's it for today. I hope you understood the session. If you have any queries, please post me. If you have any queries, I'm giving the mail ID where you can post your questions, your queries. Info, info at timeforeducation.com. Education.com. Definitely will respond to your queries. You can post your doubts to info at timeforeducation.com, and please log into our YouTube channel, Time for Bank Exams. There you will be having so many videos of number series and different topics, basics, fundamentals, everything. Okay, log into this channel and please watch the videos. Okay, thank you. Have a great day. Good night all. YouTube channel name is Time for Bank Exams. T.I.M.E time for bank exam. For is nothing but number 4. Time 4. We'll be having lot of videos. General awareness videos, quant videos, reasoning videos. Please watch those videos. You'll get full clarity. Okay, I'm winding up the session.